Are you ready, kids?
Aye, aye, Captain!
I can't hear you.
Aye, aye, Captain!
Oh! Who lives in a pineapple under the sea?
SpongeBob SquarePants!
Absorbent and yellow and porous is he.
SpongeBob SquarePants!
If nautical nonsense be something you wish,
SpongeBob SquarePants!
then drop on the deck and flop like a fish.
SpongeBob SquarePants!
Ready? SpongeBob SquarePants, SpongeBob SquarePants, SpongeBob SquarePants, SpongeBob SquarePants!
Good day, students. This is Science Classroom, and the topic for today is number theory, and this will be our third lesson on number theory. And objective: define and use law of closure, commutative law, associative law, and distributive law. So these are what we want to talk about today. We will start with law of closure. The law of closure states that a set of numbers is closed under the operation if when the operation is performed on any two numbers of the same set. The result is a member of that set. And that's basically what it is. If you look at the example here, you will see that the 8 and the 7 would in the set of natural number or whole number, right? So if I should add these two numbers, if the result is of the same set, which is whole number or natural number, then this is considered closed. Or that's the law of closure take effect. Okay? So addition, when you add any number under addition, any two number under addition, it will close. So closure law take effect. Multiplication. 5 is a whole number as well as 6. When we multiply these two numbers, right, the result will also be a whole number. So therefore, under multiplication, the closure law take effect. So we say that the set of whole numbers is closed with respect to addition and multiplication of numbers. All right? Now, if you look at example C, you will see that the 6 and the 9 are both whole numbers as well. But if I subtract these two numbers, right, I won't get a whole number. What I will get is called an integer. So the 9 and the 6 are from the set whole number, but when I subtract them, I get an integer. So that's a different set. Okay, so that is not closed. If you look at these two numbers, this -7 and the 2 are from the set integer. But when I divide these two numbers, the result I get is from the set real number. Because this is not an integer. This is not an integer because integer don't have a half in it or point. Integer are negative and positive whole numbers. Okay? While it is a negative number, it is not an integer. So we say that the set of whole numbers is not closed with respect to subtraction and division. Okay? So while it is closed under addition and multiplication, it is not closed under subtraction and division. So this is what we talk about when we talk about the law of closure. Okay? So let's look at another one here. This is called the commutative law. And what it says, the commutative law for an arithmetic operation deals with the order in which the operation is performed. And so we have two examples here that depicts that. We have three numbers, 3, 5, and 8. Yeah? And then we have the same three numbers, 8, 5, and 3. No matter in what order we add them, from 3, 5, that's 8, and 2, 8, 16, or 8 and 3, that would be 11, plus 5, you will still get 16. So no matter what order you add the number, once it's the same 3 number, you will get the same answer. That is commutative law taking effect. Okay? Likewise, if you look at B, multiplication, if I should multiply 4 plus 5, you will get 20 plus 3, that will be 60. Right? And if I switch them around, 3, 5, 15 times 4 will give you 60. So no matter what order I multiply these numbers in, they will give you the same answer. Once it's the same 3 number you multiply, you will get the same answer no matter what order. That is commutative law taking effect. Okay, so we say hence the addition of numbers and the multiplication of numbers are both commutative, meaning that no matter what order they are added in, the answer or the result would remain the same. That is commutative law taking effect. Okay. Now, if you look at C, the example C, if I have 8 minus 3 not equal to 8 minus 3 is not equal to 3 minus 8, because the result of 8 minus 3 will be 5, but the result of 3 minus 8 will be negative 5. So 5 is not equal to negative 5. 5 is a large number compared to negative 5, which is a very small number. So they are not equal. Okay? So this is what the law says. Okay, and look at division. If 6 divided by 2 is not equal to 2 divided by 6, or 6 upon 2 is not equal to 2 upon 6. If you look at the answers you get, one you will get 3, and one you will get 1 upon 3. 3 is not equal to 1 upon 3. One is a large number, one is an extremely small number. Right? Hence, the subtraction of numbers and the division of numbers are not commutative. Right? Subtraction of numbers and division of numbers are not commutative. So that's what we say. So while the addition of numbers and multiplication of numbers are commutative, subtraction and division is not commutative. Please remember to pause the video at any time to take the notes, as well as study these information, because you will need to apply them in the future and apply them correctly. Okay? Now we want to look at associative law. The associative for an arithmetic deals with grouping the number. And if you look at the first example, we give you a number. We give you 3 examples. When I add these 2 numbers from 3, 4 to 7, right? Yeah, it will equal to, if you group the first 2 numbers and then add the 7 to it, that will equal. It will also equal if I had the 4 and the 7 first, then add the 3, you will still get the same answer. No matter what order you group them into, you will get the same answer. Okay? So look at this. If I just add them 2, 3, if I multiply them 2, 4, 5, right? It will equal to if I group the first 2 numbers and multiply them, then multiply the 5, or if I multiply the 4 and the 5, then multiply the 2, I will still get the same answer. Okay, so what this is saying, hence, addition of numbers and multiplication of numbers are both associative. Okay, but if you look at C, okay, if you look at C, you will see that if I subtract 5 from 9, then come and subtract 2 from it, it will equal to if I group 9 and 5 and subtract them, and then subtract 2, it will equal to that, but not equal to if I group the 5 and the 2 and subtract them, then subtract the result of that from the 9 will give you a totally different answer. If you look at the answer here that you will get 2, which is equal to 2, not equal to 6. So the three answers you will get is 2 for the first one and 2 for the second one and 6 for the third one, which are not equal. Okay, so what this is saying, if you try to subtract them in the incorrect order, like not from left to right, or if you try to group them differently, depends on how you group them, that will drastically change the answer. Okay, so in this sense, it is not associative. Okay, look at division. Okay, if I divide them from left to right, and then group the first two numbers, and then divide the third number, I will get the same answer as the first. But if I group the second two numbers, then divide by the first number, then the result will change. And see here, you will get 1 for the first one, and 1 for the second one, but you will get 4 for the last grouping. Okay, so that is saying that hence subtraction of numbers and division of numbers are both non-commutative, because depending on how you group them, that would have changed or affect the result drastically. So therefore, subtraction and division is not associative. Okay, so the next one we want to look at is what we call distributive law. Okay, and let's look at what it says here. Let's read. The distributive law for an arithmetic operation deals with the multiplication of numbers in brackets. So let's say if I have two numbers in brackets, my computer is talking on me. So you're going to have two numbers in brackets. Let's call this 5. And it could be plus or minus in here, or 3. These two numbers in bracket, and I can multiply this. I call this 4. 4 outside the bracket. This means what is outside the bracket must be multiplied by what in the bracket. The common rules based on order of operation, you should do the bracket first to remove it, then you multiply by the other number. But based on the rule of distributive law, you can always multiply each member inside the bracket, then you add them to remove the bracket. So look at this. So this could become distributive. We're going to distribute the 4 to the 5, and then distribute it to the 3. So this is going to become now, 4 times 5 plus 4 times 3. Okay, so this is going to 4 5s, that's 20, so this will be equal to 20 plus 3 4s, that are 4 3s, that's 12. Then we can just add these two numbers and we get 32, which is equal to 32. Okay, and that would have resulted in the answer. Likewise, if we should just add the two numbers, which is 8, which we get in the order of operation format, you can just say 5 plus 3, that's 8. That would be 4 times 8, which is equal to 32. Okay, but we are looking at the distributive law principle of multiplication. Okay, so this is one example. If you want to do another example, let's do like 3 outside the bracket and put 5 here and put 2 here. Okay, and then we can do the same thing. Okay, so this is a 3 5 is 15. Oh, I put a multiplication sign in the bracket. It should be an addition sign. Let's remove that and fix it. Okay, 3 2s is 6, so that will be plus 6. And the answer and the result would equal to 21. Likewise, if we did add the 5 and the 2, we would get 7. So that would be equal to 3 times 7, which is equal to 21. So the distributive, we just proved that the distributive law principle works for all operation in this sense, where are two numbers to be added in the bracket and one outside to be multiplied. You can distribute the multiplication to all the numbers inside the bracket. It can be 3 or 4 numbers in the bracket to be added. You can distribute the multiplication to each member inside the bracket, and that would have given you the same answer. This becomes more needed as we approach algebra, which is what we're going on next. That is the first topic we're going to start. We're going to look at indices in algebra term and then move on to other algebras from there. So this is why you need to understand this part of it. So when you start to do it in algebra, you are familiar with it. Okay? So that is what we want to talk about. So hence, we say that multiplication is distributive with respect to addition of numbers as well as subtraction of numbers. So it could be, let's do another example with a subtraction in it, because we don't want somebody to say that it's only addition we do. It can only work with addition, but it also work with subtraction. I'm just erasing this one to give me some space. So please remember, you can pause the video at any time to write off any example I did. Okay, so this one, let's say I have 2 outside here, and I have 8 minus 5. It works just the same. We can use distributive law to multiply by each member in the bracket. Okay, so this is going to become now 2 8s, 16, so that will be 16 minus 10. And that when you subtract 10 from 16, you get 6. Likewise, we could actually subtract these two numbers and get 3. So that is equal to 2 times 3, which would equal to 6. Okay, so these are basically what you will want to look at. And you will see that you get back the same result no matter what. But the distributive law principle come more needed and when you're looking at algebra. Okay, because sometimes you're going to get A and B inside the bracket and you can't add A to B because you don't know what the variable A is and the variable B is. So you can't add two numbers, you don't know what they are. So you'd have to add, you'd have to multiply what's outside the bracket by each member to simplify. So these are some way you're going to need to use distributive law. And all these associative and commutative as well as closure law is going to come more needed as we approach algebra. So please study them, know them, so when you're going to algebra, you will have it much easier. Thank you for watching this video and give it a thumbs up and subscribe to my YouTube page. And yeah, study hard.